And welcome back to part 2 of the networking tutorial. In the first part we discussed the client-server relationship, and in this part we're going to utilize the gained knowledge of this, and we're going to show the code that's required to basically be able to network. So let's get started. So to resolve our problem we're going to need some more infrastructure. Now let's create a new class, and let's call it network. We put it in a new network package, and we call it a network handler. And from this class, we're going to send all our packets. So we can do that. Now, in this network handler, I'm going to employ the SimpleNetworkWrapper, as it's called. It's a feature added by FML. And there are a few options to there. You can do the SimpleNetworkWrapper, and there are a few options, but we're going with this one because it's in the name. It's simple, and most of the things you're going to do with networking, you can do with the network wrapper. In pneumatic graph development, I haven't come to a situation yet where I needed something more than that. So we're going to use this as well. So let's do it. We're going to do public static. Oh, we can do private actually. Private static simple network wrapper. Let's call it instance equals. We're going to get a new instance of this simple network wrapper. We do new channel, and let's do new simple channel. We're going to use the channel name. So basically, every mod gets its own channel. That's the idea. You can have more channels per mod, but we're going to use one. So we're going to pick a name that has a low chance of other mods being copying them. So let's use the mod ID. So we can use the reference. This mod ID is fine, so we can do reference.mod ID. It might be better to do it right when we want to. So we're going to initialize this network handler in our pre-init. So at that time we can instantiate it. And in here we're also going to register every packet we're going to make. So every different message is going to get a different packet. So let's create a packet. Let's call it message, or well, let's do message. Message base. I think that would be neat, and we can do interfaces. iMessage. These are just things you need to do without asking. These are basically you're going to add the way of processing the packet to here. So every let's do that. And this is our base class. these are one of the few occasions where I'm not going to really explain what I'm doing. I'm going to copy something from SimpleNetworkWrapper, which is really a nice thing to have. So this is an abstract class we're going to work with, and we can do... Let's just make this null for now. And... okay. So what we can do here is we can create a new... So this is our base message. We're going to call our packets messages now. This is a base message. Every message we're going to make, so we can make a message explode, is going to extend message base. And you just need to give it the same type over here. And now you can implement this. So in the PowerPoint, I explained that you can add additional information. You can send additional information to a message. So you can add information, and you can extract the information. And so for every packet you might want to add information, for others you might not. We are going to leave this empty. We aren't going to add any extra information. But over here we can, and over here we can handle the packet. So we can handle client side. If you look at the message base, this generic method will be called when a packet is received on either the client or the server side. So, and if we check if we received it on the server side, and we received it on the server side, we're going to call this abstract method. And if we received it on the client side, we're going to call this abstract method. So here on the server side, we can say, oh, this message was received on the server side, and this player sent it. So if you receive packets on the server side, you get it from a certain player. If there are 3 players and they send a packet, one player sent a packet to the server, this instance will tell you which player sent it. And we are going to use this for our explosion packet. We don't want to create an explosion under another player, do we? And on the client side packet, I've added this. We could just remove this. It doesn't really matter, but we can also leave this, because this player instance will be the player that received it. But if you're on the client side, you could already get the player by doing that, and that will be the same player. There is something with that, but I'm not going to go into that right now. I might do that in a second, but for now I want to finish up the main goal of today's episode. So let's do that. So for now, this instance always will be null. I will resolve that after we finish the main goal, as we are not going to use client received packets at the moment. So our message explode, we're going to leave this empty, and when we receive it, we want to create an explosion at the player XYZ. So we can do player.world object, create explosion player, the player.x, player.y minus 10, player.z. We wanted to have it as big as a creeper, and we want to break blocks. So that's about it. We're totally going to ignore what's in the message, because we didn't really add anything in the message, and that will be fine. So we need to register this message basically. So we're going to our network handler and we're going to say instance register message, and we're going to do 2 times the same because I've set it up like that. Our message base both implements iMessage and message handler. So what this means, basically I've set it that this class can construct a packet and it can handle a packet. I like to keep it together. You could separate it if you want. I don't. So I'm basically saying the processor and the sender of the packet, the class. And discriminator is basically the ID of the packet, so we can just do null for now, or 0, I mean. And if we add more packets, we could do something like that and do a 1. And now the side is the side of which side is going to receive the packet. So that's the side.server for, in our case. There we go. And that should be about it. But this init isn't being called. So we still need to do that. We can do that by going into advanced mode and do it over here. We can do it after the world generator. Sure. We can do network handler.init. So this will be called, or we get a channel and we register a packet to that channel. But we still need to send a packet. We have a way to receive it, but we haven't sent it yet. So what I like to do in this SimpleNetworkWrapper instance, there are a few methods we can use. You can send to the server, which we're going to use. You can send to all players neighboring a certain XYZ, or send to all players. And you can send to a specific player, and you can do all kinds of things. And I'd like to expose those methods over here. I don't want to somewhere like over here. I don't like to do network handler.instance.send to. I like to do network handler send to blah. So I like to expose those methods that are over here. So we can do public static void send to server, and we could do message base message, or we could do iMessage. I could do instance send to server. So let's use it over here. We can remove this. This was rubbish. And we can do network handler send to server. And we can do a new message explode. And let's try this. So I'm in my test world again. Let's press G. I think it works. I don't get stuck anymore. Items are being dropped. And probably we are going to die. We can kill entities. There we go. I think it worked. So this is a little bit OP, but I couldn't resist playing around a bit. It's too fun. And big explosions. I upped it to 30. So that's 10 times the power of a creeper. Now, I'd like to show you how you can add additional info to packets. So maybe we could add another key. So we've got G for just the normal, for the explosion size of a creeper, and do H for 30. We could make another packet, one for 30 and one for 3. So 2 packets in total. But it's nicer, I think, to do it this way. We're going to add some info, so we can do a constructor of a message. We can add an explosion size, and that will also be a we do that. But you need to be careful here, because you are going to, on the client side, you're going to use this constructor to create this message. However, on the server side, this class gets instantiated via something else called a function. But it doesn't know that it needs to give it a float, so it will crash if you don't do a empty constructor as well. So we need to do that, else it will crash. So we can use this explosion size, and we'll explode by this value. Now we haven't really transmitted it yet, so we're going to do that now. So we can get the explosion size by this byte buffer. Byte buffer basically holds all the extra packet information. You can use that to add information of your own. So we can do a get float, or read float rather. And every bit of info you add needs to be in order. So if you do a write float, and we do an explosion size, and if you would, I don't know, have another value, or boolean blah, and do blah, or let's do the other way around. If you're going to write that boolean, you do write boolean blah. That is in order. So first the explosion size is being written, then blah is being written, and the order of reading needs to be the same. You can't do blah equals buff then read boolean. That won't work. You need to do it in order. So I need to do it like here. So like I said in the beginning, you can read all primitive types, floats, doubles, booleans, integers, that kind, and more. You can do above that, and you can see all the things you can do. Yeah, that doesn't really help. And even if that's not enough, you can do byte buff utils, and there are a lot of other things you can write and read to a byte buffer. So you can write an entire MBT tag. We still need to dive into that, but then you know you can't. And you can write an entire item stack to it. And if you look at the implementation, you'll see it will come down to writing primitive types. But it saves you the time doing it yourself. So we're going to do it like this. Now it's really important, I've made a next mistake here, it's really important if you're going to make this class a creator of the packet and also a processor of the packet, you need to be careful that when you're doing this explosion size, this isn't the right variable you're accessing. You want to access the explosion size in this instance. So you want to do that. Now let's do this, and we need to create another key. So we can go in our keys and add a explode big. And let's do the H key. And that should do it. And we can do a do it like that. Explode big. Let's see if that works. I think it does work. Let's see. Let's dive into the ground. Do a small explosion. I press G. So just doing small explosions now. And if I do a big explosion, that happens. And you get the weirdly shaped explosion, like you know when you blow up a industrial craft nuke or whatever. But yeah, that's about it. It works. So our main goal is done now, but I'd like to show another example. And that has to do with methods that are being called for both the client and the server. So if we're going to, for example, create an explosion when we right click a flag, you'll see the problem. So let's stop emitting a sound effect and do a wall.create an explosion for the player, sure. X, Y, Z, 3, and break blocks. Let's find a flag. Now you'll notice that blocks are being dropped. However, I just got stuck in a block. Oh, there we go. So that's the same glitch we got last time. If we relock the blocks, probably will appear again. So these are blocks the client decided to remove, but the server didn't. And due to the nature of Minecraft, the fact that it's being random, every random thing needs to be done by the server, and then the server needs to notify the client of what's actually happened. So explosions are a good example for that. If when an explosion occurs, random blocks are being broken. So on the client it decided that it randomly wanted to remove this block. However, the server said, nope, I don't want to remove that block, I'm going to remove another one. So we need to make sure that this method that's being called on both the client and the server side only needs to be called on the client or on the server, sorry. We can, by the way, prove that this method is being called on both the client and the server if we do a log.info blah. And if we right click a flag, you'll notice that in the chat 2 times the blah is appeared. So that's 1 time for the client and 1 time for the server. So if we want to only execute this on the server side, how do we do that? We can do that by doing world.isRemote. This is a boolean that you can't do that. Okay. This is Boolean. That's true when it's on the client and false when it's on the server, like it says over there. It's really useful. You can use it most of the times, or all the times when you've got access to a world. So that way we only create an explosion when we are on the server. So we won't get fake blocks when we shouldn't get any anymore. At least. Let's see if I do it over here. Well, I can't prove it, of course, but I could do a log. And only one time blah appeared, and that's on the server side. So most of the times you can do that. If you really don't have access to a world object but do want to know on which side you are, you can always do fml common handler instance get effective side. There you go. And you can do if that's equal to site.server. That would be the same. However, if you do have access to a world, it's highly recommended to use world that is remote. And you don't really often need this. I don't think I've come to a situation yet where I needed it. I always had access to a world object. So this concludes this episode on networking and the client-server relationship. I hope it was clear because it's a really tough subject that many people appear to have problems with when I looked at the Minecraft Forge forums. So I hope I was clear. I hope you got a good base on what it's about, and when we're going to build on top of this concept in the very next episode already, when we're going to dive into time entities and inventories and GUIs. So for now, see you all next time, and thank you very much for watching, and bye bye.